Okay, everyone. Welcome to this week's nature seminar. It's great to see a really good turnout for September. So it's really testament to the star pulling power of our speaker today. Before I introduce our speaker, I just wanted to mention that this is, for many of you who know this already, but for those who are new, this is part of our regular Friday nature seminar series, for which we've got a very full and packed program this term. Just go to the Biodiversity Oxford network for Oxford University if you want to see the detail of the program or register for particular talks and see the details, and also to get onto our mailing list if you want. But just to mention some of the forthcoming talks, next week we've got Miles Richardson from the University of Derby on fixing our broken relationship with nature and about nature connectedness. And so that's next Friday. The week after, we don't have a Friday seminar, but on Thursday we have our visitor Earl Ellis, who's somewhere in this audience, I think, who's going to be talking about a flourishing vision of the Anthropocene, and that's going to be at the Martin School on Thursday at 5 o'clock. But you have to register for that, so go to the Martin School website and click and register for that one. It'll probably be full, so I recommend registering sooner rather than later if you want to go to that one. The week after, we'll be doing a screening of the Good Natured Film Festival, the nature recovery films in the festival that we held this summer. So that'll be a movie night. And the week after, we have Rob Ewers from Imperial talking about a virtual rainforest. And there's lots more for the rest of the term that I won't go into now. There's a fantastic array of talks. So it gives me great pleasure to introduce our speaker for today, Professor Dame E.J. Milner-Gulland. She's the Tasso Leventis Professor of Biodiversity at Oxford, where she's Director of the ICCS, the Interdisciplinary Centre for Conservation Science, which is based in the Department of Biology. And she works on understanding and predicting and mitigating biodiversity impacts and monitoring and evaluating conservation interventions for their social and biodiversity outcomes. And this includes programs on food systems, nature-positive transitions, the wildlife trade, social justice and equity, and probably many other things on top of that as well. And she's also launched a number of initiatives which aim to change the real-world conversation around conservation, including the Nature Positive Universities Initiative and the Conservation Optimism Movement. And she's chair of the UK Government's Darwin Expert Committee and a trustee of WWF UK. And this year, for all her work and endeavours, she was made a Dame in the King's birthday honours this year. So congratulations for that as well. And with that, I want to say over to you, Jay.
Thank you very much, Jedlinda. Thank you for the invitation, and thank you to everyone for coming. I thought if I made a really annoyingly provocative title, it might tempt people to come along, so seems to have worked. So yeah, I'm going to be talking about biodiversity metrics, and I illustrate some nice biodiversity for you. So is that okay? Is that working? Yeah. We're often told in the biodiversity world that what we really need is a kind of lodestar like climate change have. So they have the lodestar of 1.5 to stay alive, and then they have tons of CO2 equivalent as their metric. So if we as biodiversity want to get ahead, the story is we need to have this same kind of lodestar and metric. After much anticipation, in December 2022, we had the Global Biodiversity Framework signed under the Convention on Biological Diversity. And this, for me, for the first time, did give us a bit of a lodestar, which is the mission for 2030 to take urgent action to halt and reverse biodiversity loss. So that halt and reverse could be seen as the kind of lodestar for biodiversity, just as 1.5 is for climate change. And we've got a nice graph here, which is very widely used, which kind of illustrates where we're trying to get to, that we have a decline in biodiversity going on at the moment, going down to 2020. Then that decline will continue for a little bit, then start to reverse. And then by 2030, we're back up to where we were at 2020. And then we have the glories of full nature recovery from up to 2050 and a thriving, healthy planet. So that's where we as a community are perhaps trying to aim for. But what is it that's in that dotted line is the question. What is that? What are we saying when we mean biodiversity? Of course, we have a definition of biodiversity, and this is the rather nice one from the Convention on Biological Diversity. And it explains that, you know, we have this huge variability that we need to conserve in all sorts of different ways. So we've got genetic variability as illustrated by these maize pods. We've got species diversity, we've got ecosystem diversity, that nice bottom picture, and we've got functional and process diversity, which I've illustrated by a migration. So all of those things need to be included in any thinking about diversity. It can't just be something like species richness. So when we think about that complexity, we then realize that biodiversity is pretty much an unobservable state. It's a concept and it's a value, but it's also, when people say biodiversity, what they really mean often is a proxy. When they say biodiversity, they're often meaning species richness, for example. It's also something that means different things to different people. So as biologists, we might want to maximize it because the general kind of thing that unifies biologists perhaps is that we like lots and lots and lots of variability. But resource managers or conservationists might want to optimize it. Governments might trade it off against priorities like social well-being. And individual people value it in a subjective way. And you only have to look at the news about the sycamore that was felled yesterday to realize how much people value elements of biodiversity. So given that and given the definition, we have some really key issues that we have to address if we're going to get to that kind of metric for biodiversity that can be taken forward. The first one is obviously this scaling, the fact that biodiversity is incredibly heterogeneous, so it's local. You know, so the biodiversity in Oxfordshire is going to be different to the biodiversity in Pembrokeshire, is going to be different to the biodiversity in Gabon. We can't therefore have a fungible metric. What I mean by fungible is something that, like money, that can be traded so that one unit is the same wherever you do it. Tons of CO2 is a fungible metric, but why it's eluding us is that this fungibility is just not really conceptually or practically feasible for biodiversity. So what's the Convention on Biological Diversity doing with respect to its metrics for biodiversity? So I thought I'd just take the 2050 goal to give you an example of what the state of play is. So over the last many years, people have been working on what are some headline biodiversity indicators that could be used at global level. And there's been quite a lot of work on which ones might be suitable at global level. And this is what was approved to date at Montreal. So for the biodiversity goal of thriving biodiversity by 2050, we've got 4 headline indicators that are stated by the Convention on Biological Diversity. One's an ecosystem one about threat to ecosystems. One's about extent of natural ecosystems. One's about threat to species. And one's a slightly random one. I don't know at 3 a.m. what people were thinking for that one, but I'm sure it's a great indicator. You can then go down a set and you can talk about the component indicators. So these are indicators that are used for aspects of the goal that are suggested to national governments as suitable indicators. So here we start to get ones that are a little bit more ecosystem based, a bit more about connectedness, some of the things that we know are really important for biodiversity, and some of our most favorite and well-loved indicators like the Living Planet Index. The CBD lists another set of indicators now called complementary indicators, which are optional ones that can be used for thematic or in-depth analysis. Here's some, and you can see they're all to do with wetlands and trends in various extent of particular wetlands. So I've just cut and pasted from the CBD website. So page 1, page 2, more indicators, page 3, and a nice picture of diversity, which I don't think any soil diversity really makes it in. So we've got like a ton of indicators. We're very far from the one true biodiversity metric at the moment globally. Why would we want to have one true biodiversity metric? Well, let's look over the fence at carbon and start to feel a bit jealous. So with carbon, what you can do is things like this. I should say that I'm going to quote a lot of different papers in this talk. The ones where I've just put a quote at the bottom like this are papers that had nothing to do with me that I just like. The ones where there is a picture of the first author are papers where I was involved. That's your little cue. So I was not involved in this paper. So this one, this illustrates why it's useful, because you can get the overall global effect of something on climate change, and then you can break it down by sector, and you can look at trends over time. So, and then you can look also at the components of that indicator, so the different greenhouse gases that have come to it. Once you've done that, then you can do some of these really cool analyses like Mike Clark did, which is about the food system. And this allows you to think about, all right, so if on the dotted lines, you've got the probability of breaching our lodestar targets if it's 1.5 or 2, and then you've got different policy options for how to change the food system. And that would be really cool to be able to do for biodiversity, wouldn't it? Question then, surely we already do this. So for example, here's the paper that we published about the impacts of Oxford on biodiversity. And here we have, you know, broken down by different operational levels, just like that first graph. And we've got the relative value of biodiversity impact for Oxford, led by Joe. This metric is species.year, and the total impact on an annual basis of Oxford University on biodiversity is 2.21 species.year, and you know the biggest one is 1.44. Okay, great. So what does that mean? So this metric is something that's used in life cycle assessment. Life cycle assessment is a really powerful methodology that's been widely used over many years. So you've got this set of categories of impact that a company might have, and you've got areas that you're concerned about. So for example, for biodiversity, land stress is one of the big impacts because that's about change to land. And the indicators that are to do with biodiversity are these kind of ecosystem quality ones. So species year comes from potentially disappeared fraction of species, which also doesn't really help you, or me anyway. So in an attempt to try to understand what this biodiversity indicator is, you can go into something here, which is the kind of life cycle impact assessment toolkit. And you can see here that what they've done is they've looked at the effect of a particular sector or particular impact on transforming or degrading land. It then goes to a species area relationship. So the relationship between species loss and the area, and you can use that and calculate it up to get regional or global loss of species based upon the area that's been degraded or damaged. So that's one example of how people would calculate this. Now we've got some amazing work going on in Oxford at the moment, which is the Hestia platform, which is led by Joseph Poor. And this gives you an example of the kind of things you can do with life cycle assessment. So this is flax in Italy in 2012. It's a paper about the environmental impacts, probably uploaded by someone in the audience. And you can see here the kinds of operations that are being done for flax. And then I've just followed it through one, so diesel to carbon dioxide emissions, which then leads to eventually damage to human health. So you can do this also for biodiversity. I think there's less of it. Valentina will correct me, but here's the same paper, and this is a ecotoxicology effect on human health from a pesticide being used in the field. So that's the kind of thing that you can do. So is species.year, or potentially disappeared fraction, the metric that we need, given that we're not very far into the talk? So the first thing to mention is that the life cycle assessment framework is a framework. It's not a metric. So the biodiversity element within it is substitutable. So although PDF is one that's used for LC impact, other approaches use different metrics. So GloBio, for example, uses mean species abundance. Within it, you could use the LD50 for ecotoxicology. The PDF is for land conversion. So biodiversity metrics can come in and out. It's really good because it enables us to include biodiversity into broader life cycle assessment frameworks, which are extensive and sophisticated. So if we think that PDF is good enough for biodiversity, which we did in our Oxford paper because there wasn't much choice, then relative biodiversity impacts can already be compared across operations through these direct and these indirect pathways. But the biodiversity metrics we have in LCAs are currently species-based. So I've just said, you know, there's a whole lot more to biodiversity, and they're not particularly sophisticated if they're still based on species area relationships. They also only have a subset of the threats. So overexploitation and invasive species, for example, are obvious threats that aren't included yet. The models are very complex and it's rather hard to disentangle the underlying assumptions. That might just be my ignorance of life cycle assessment. Key, though, is it doesn't give you actual biodiversity loss from your particular product or your particular supply chain. It gives potential loss based upon these models. So it doesn't help you to get down deep to what's actually going on. Another thing that's important, which is people are starting to test, is that different approaches to including biodiversity give different results. And that's quite normal in models. Here's a nice example. Again, nothing to do with me. So this is the biodiversity impacts of EU consumption. And this nice paper looks at 8 different models, some of which have different biodiversity metrics in them, and then looks at the different contributions of different kind of parts of our consumption. Now, my question when looking at this is this good enough? Because in some senses it is. It's quite comforting that across the models, I don't know if it's comforting or not, that food comes out big. And that the relative impacts are perhaps across most of the models fairly similar. So maybe it is good enough, but there's certainly difference across the models anyway. So just to kind of summarize this chunk of what I've been saying, we've got 2 intersecting contexts here. We've got the company sector biodiversity impact mitigation elements towards individual contributions to the lodestar, which we'd call biodiversity, bend the curve of biodiversity or nature positive, call it what you like. And then you've got your national to global monitoring of progress towards an international lodestar global biodiversity target. And those 2 things intersect, but they're not the same. So an LCA would track impacts across products or across supply chains and need to include biodiversity and can be used to help companies think about their contributions towards the global target. But LCA is not made to help us to think about how our overall, as countries or as a planet, we're actually moving towards changing the curve for biodiversity. That's not what they're made for. So although that seemed like a really promising avenue, and it is in some senses, it's not all the way. So we can go back to some work that was done, led by Julia Jones, quite a few years ago now. Last time we were thinking about the Global Biodiversity Framework, in fact, and we thought, okay, what would make a good biodiversity indicator that would enable us to track biodiversity trends at a global level? And we came up with this list of things, and I'm going to talk about 3 of them that I think are the most interesting ones. So reliable information on state of biodiversity, responds predictably to policy, and informative across scales. So number 1, reliable information. This is, I'm just going to give you a couple of examples. And the first example is some unpublished work, so don't tweet it, please, which is done by Tom Atkins and Nat Duffus, supervised by Rich Grenyer and Owen Lewis as part of our Agile project, of which I was the PI. So here's Nat and Tom looking really, really pleased with themselves with a fancy biodiversity monitoring tool, basically a vacuum cleaner. And what they were doing is they were trying to think about how the Natural England or DEFRA biodiversity metric, version 4, relates to a more concrete proxy for biodiversity. So the biodiversity metric is a proxy for biodiversity that is based on habitat. And the idea of it was to allow anyone across England, however capacitated they were, to get some kind of understanding of the gains and losses of biodiversity that come from development, any kind of development, and then mitigation compensation actions that happen. So that table came from the Natural England website and is a kind of nice worked example of how you might get a number for the amount of biodiversity units that you would lose from putting some houses on a place, and then therefore how many you would have to gain somewhere else. So the proxy comes from a calculation. You get the size of the area, you multiply it by the distinctiveness, of which there's 3 categories. You multiply it by the condition of the area as it currently is, of also 3 categories. The strategic significance, which is about the extent to which it's part of things like the local nature recovery networks. If it's pre-development. If it's post-development, you also add in some risk multipliers about how difficult it might be to make that biodiversity happen, time lags and things, and that will give you your biodiversity units. So Tom and Nat set out, and here they are in the field again, to see the extent to which these biodiversity units actually relate to real-world biodiversity, in their case, species richness of various groups. So the first answer is for floral biodiversity. So that's species richness of plants. And the first graph is the distinctiveness component of the unit. So that is it a really kind of important bit of habitat? And you can see the confidence intervals and the dots, and basically high distinctiveness, or so medium distinctiveness of the grassland is better than low distinctiveness grassland. Hooray. And then the second one is the x-axis is the number of units on the biodiversity metric that you get. So the more units, the more biodiversity is against floral species richness. And you can see there's a nice correlation there, which means that the more species rich an area is, the higher it scores. So that is also good. Here's the result for birds. Not so good. Here's the result for a bunch of invertebrates. They're very keen on invertebrates, so they did a lot of invertebrates. And you can see here, not so good either. So the answer is that the metric, being habitat-based, is not a good proxy for species richness, one element of biodiversity, other than floral. So then you might say, all right, so we can't just use that if we're going to think about the biodiversity damage of housing, for example. Here's my second example for this particular element. And that's just to remind us all that just because you've measured something yourself doesn't mean it's true. So all measurements of biodiversity have biases and uncertainties. So when we're thinking about the extent to which biodiversity metrics of any sort have are reliable measures of actual biodiversity, we need to think a little bit harder than just counting and saying it's all right. And this is just not, I promise, a bit, an excuse to get Saigers into my talk, because Saiga antelopes get into every talk I give. These are Saiga antelopes, a great species. They're counted by aerial survey. Now, if you this is a picture that was taken from an aerial survey aeroplane. And so if you look, you can start thinking for yourselves, what are the key areas of bias here? And once you've thought, I'll give you the answer, which is distance. So the further into the distance you go, the less likely you are to be able to see and count Saigers at all. Group size. So the bigger the group, the more likely you are to see it. So if there are small groups around the place, you're less likely to see it. And the actual area covered by the transect of the aerial survey will also be an issue. So this is some work that was led by A.J. McConville. And we had some issues for Saigers a few years ago in which the population crashed. So here is, based on the aerial surveys, the population trajectory for Saigers in Kazakhstan. So we had this massive decrease in recorded total population size. We also had, and this is the thing that's less noted, a decrease in group size, because as the population got smaller, it started to fragment into smaller groups. So you can see in the 90s, when the population was large, we had them in very, very large groups. And then in the 2000s, mid-2000s, when it was small, we had most of them in very, very small groups. And so that group size was a bit of an issue. So that means we've got a change in our count bias, remember, from the three things that I mentioned. Now, we did some modeling, and I won't go into the modeling. And what we found out was this is how it affected modeling, monitoring reliability. So this graph is a little bit hard to read immediately. So let me just clarify. So the dot is which I've put as 1, is the survey estimate. So that is the estimate that came from the observation. The confidence interval, 95% confidence interval, is what the modeled actual population size was. So it's a flip, really. So that confidence interval tells you where the population size, the true population size, will lie. So in 1998, when the population was big and there was much less bias, it was right in the middle of the true population size. In 2006, it was outside the 95% confidence interval for the population, so way off. So just to highlight what the implication of this was, is that as the population crashed, the observations suggested that it was much worse than it actually was. So the observation made it look like it was declining far, far, far faster and further, because the bias was getting worse and worse and worse. As the population starts to recover, then the rate of recovery might appear much more rapid than it actually is. And in fact, that's what we've seen. We've seen a massively rapid recovery, which may or may not be true. So that reminds us that we really need to think about the biases in our population models, which brings me on to the second one. which is responding predictably to policy change. And this is work that we did that was led by Emily Nicholson some time ago. And the main thing that we were trying to put across here is that models are really powerful tools to help you to think through biases and scenario plan whether or not your biodiversity metric is actually working. So there's a diagram that basically says that you have the real system, you observe it, you model it, and then you use those models to try to understand robustness. Here's an example. It's quite, and I'll just talk you through this example. It's about the effects of a ban or a halving of bottom trawling on one of our favorite indicators, the Living Planet Index, one of the global indicators. So the Living Planet Index is a geometrically mean weighted index of change in abundance of individual vertebrate populations, aggregated. So we would think that a ban or halving of bottom trawling was unambiguously good for biodiversity. And this is modeled over 30 years using a really complicated ecosystem model called EcoSim that models kind of ecological relationships between a range of different tophic groups. It's the nearest we can get to a model of reality that we have. So this is within EcoSim. So first of all, one thing to notice is for these different global ocean basins, what we see over 30 years is that according to the Living Planet Index, things have got worse as a result of banning or halving bottom trawling almost ubiquitously. So surely that's wrong. And it probably is wrong because if you look at vertebrate biomass in general, so total vertebrate biomass, in general, that is increasing as bottom trawling is stopped or halved. So that is a more expected signal. Then you can go into detail and think, well, why is it that this particular headline aggregate index is not perhaps capturing what we would expect? And the answer is that things are complicated in ecology. Surprise. So if you just take this couple of rows here, what it is that changes are feeding through the ecosystem. So in particular, seabirds do well out of bottom trawling because they get all the discards. And so seabirds are declining when bottom trawling stops, at least into the first 30 years. And that is kind of, and so we've got declines or increases, and the strength is the weight of the arrow. And then the little tilde, the wobbly one, says mixed ambiguous results. So when you look into ecosystem effects, which is a different kind of way of thinking about biodiversity, you might find that your metric is not actually representing policy change, the expected result of policy change. So that should be being done for every single metric. You know, all those metrics that I listed should be having robustness tests. Otherwise, you know, we're worried because we don't really understand how they work. This is a nice piece of work that Emily Nicholson led later. I'm not involved, in which they looked at some of the most popular global biodiversity indicators, and all our favorites are in there. You can see yours. And they looked at it according to a range of different things that would make for a good indicator and checks that they'd actually been properly tested. So have these been properly tested? A couple of things to note. First is that the places where the most concerning lack of testing is uncertainty. So how does it respond to uncertainty? How certain is it? And then the second one is cost effectiveness. So we can live perhaps without cost effectiveness, or it's important, but the uncertainty one is really important. We can then have a kind of list of indicators that really need a bit of work. And I've put some red arrows on the ones where on a number of different dimensions, they're not yet ready for global application until this has been sorted out. And I'll have a positive list as well of ones that have been well tested and well validated, in which the LPI is one. So I think much more of this needs to go on, and it's so easy. If you look, everyone's proposing like a ton of new indicators all the time. Everyone's got their perfect indicator. Have they actually been through and tested it properly is a question that we should be asking, because without that testing, you don't know how it works. Now I'm going to have a good example, and I'm a little bit biased because I'm involved in this, but this is the green status of species. This is an example of really robust testing that was led by Molly Grace out of Oxford University. So I'm not going to go into great detail now about what the green status of species is, but I would say it's part of the family of IUCN indicators. You are, how threatened you are. The green status of species tells you how close to recovered you are. It's a flip one, it's more positive. So here's an example for the osprey, where it's least concern on the red list, but it's largely depleted on the species recovery score. Okay, so this index was developed, and then a huge program of testing over several years was conducted, explicitly trying to get a broad range of taxa across a broad part of the world. So the colours represent the number of taxa across these different parts of the world, marine as well as terrestrial, involving like a ton of people. It was really important to make it participatory. Lots and lots of specialist groups, lots and lots of people in lots of countries. So I'm not going to go into great detail about the results, but here's a couple. The first one was just the top shaded one, is just to show that they managed to get a spread across the whole range of species recovery score from in good shape to in disastrous shape. Because they're conservationists, a lot of them were largely depleted. That's what the big spike is. But, you know, there was breadth across there. One of the nice results was about uncertainty. So we'd set 40% as the uncertainty level beyond which you can't assess the species. You could see that the uncertainty is mostly relatively low. So although maybe the data aren't great, most of the species, the vast majority of the species, could be assessed with quite good certainty as to where they sat in the species recovery score, which is important. And then this is just one example of an analysis, which is the relationship between the species recovery score and the red list category, which shows, not surprisingly, that more endangered species are less recovered, but there is some variation which shows that the species recovery score is capturing something different to the red list. So that's that. Next question, can it be aggregated across scales? And this is where we start to get a little bit sketchy. So this is just my suggestion of how to do it, because this is where we haven't really got there yet. This is the kind of crunchy one. So my suggestion here is that we use a bundle of suitable metrics that are appropriate to the given scale or location, so including a range of different metrics like we have, to measure current biodiversity and to express desired future state for the biodiversity. Now, expressing desired future state is a value judgment, but we're already making value judgments all the time about biodiversity. So why don't we just be explicit about what our desired future state is and stick it in there? Second thing then is that you could have a set of metrics, you would want to have it mostly about outcomes, so real measures of biodiversity, but you could also have metrics that focused on drivers, for example, so that we saw how threats were reducing or positive benefits were increasing, and then also perhaps even process. So have you got a species action plan in place? Those are all relevant metrics. For each metric, you then express your progress from the current state to the desired state on a consistent scale, so 0, 1, or as a percentage. And that is the thing that allows you to kind of compare that expression. You can then compare in a relative way how far for each metric you are towards your desired state. And then you can aggregate using those relative metrics. This is just still thinking, so there are some unresolved issues. Double counting is one that, you know, if you're doing biodiversity on a range of different metrics, you'll be double counting some of the biodiversity. You might miss key elements of biodiversity, but we're already missing key elements of biodiversity, so we just have to get some better metrics for them. The one thing that I think needs to be underlined is that this is not fungible. So I think people are always, and I'd love to have a discussion about this. I think people are looking for the fungible metric because they want to be able to say, you know, a unit of biodiversity here can be compensated for a unit of biodiversity there. This would not do that, but I don't think that biodiversity is fungible. So I don't think we should be looking for a metric that gives you fungibility. That's something to discuss, perhaps. And that's a random picture of tigers. So some metrics do already suit this approach. So to go back to the green status of species, that is a metric that already uses this kind of approach. So here's how you make a green status of species in 20 seconds. You define the range of the species. You divide the range of the species into meaningful, biologically meaningful, ideally spatial units. You then assess the status of the species in each unit on a simple 4-point scale of absent, present, viable, or functional. You then aggregate that up to get a percentage fully recovered across those units with a weighted average. So the idea then is that you're representative across the range, you're simple enough that people can use it, and you've got some kind of recovery status thing. And here's the kind of thing that you would then get. So a species might be currently about 30-something% recovered. The shaded thing allows you to do a counterfactual to say what would have happened in the absence of conservation. So we're currently 30, but we would have been 10%. And then in the short-term future, if we implement all the things in the action plan, where would we be? And where would we be if we didn't implement those things? And then where are we aiming for? We're never going to get to 100% recovery because the world has changed. But we could get to much higher than we are. So that's what the green status does. So that would be very, very easy to put into this framework that I suggest. But there are others. One is the Living Planet Index. And because everyone's bored of seeing the Living Planet Index going down by 70% in our lifetimes, I thought I'd give you Europe and Central Asia, which may or may not be slightly more positive. There's also another really popular one, which is the Biodiversity Intactness Index. It's also similarly constructed. So there's lots of indicators that could already be doing that. There's also organisations who are starting to do it this way. So this is Accounting for Nature, which is an Australian organisation that is starting to collect robust biodiversity measurements and then saying, you know, you can look at relative change using them. So how would this work? So at the country level, for example, you would identify target levels of biodiversity that you want in your country, timescales by which you want to get to them. You would then choose your scale appropriate indicators and your measurement approaches. So a high level appropriate index might be something that everybody loves, like an elephant. That would be what your global national priority might be. But then you would have your local indicators, your bottom-up indicators that would be what the local people actually care about. So that might be wetland integrity, wetland quality, for example. It might be something much more relevant. You would then monitor each indicator, and is the progress as planned moving towards nature positive in the right way? And, you know, maybe you have a kind of traffic light score for doing that. And then you can report across scales and analyze and adapt either at local or global level. So that is my pitch. You can do the same thing for companies. So again, you could have your indicators. You could use potentially this period fraction if you wanted. You'd report at global level to things like the Task Force for Nature-related Financial Disclosure or the science-based indicators. And at local level, you would use company level priorities. And that might be something, elements of biodiversity on which your operations are dependent. So that might also be clean water, for example. And then everything else is basically the same. So say you have that framework. What does that then imply? Once you've set your biodiversity targets and you've started to monitor towards them, what we will find is that massive financial transfers are required for biodiversity conservation from wealthy countries to biodiverse countries. And that will be needed to compensate for our impacts. And that will need to happen in the short to medium term alongside systemic change, transformation for that of whole of society towards a nature positive future. That's just in the absence of immediate systemic transformation. I was going to say something about Rishi Sunak, but I won't. Then there will need to be some short to medium term compensation. Here's a nice paper that I just found, which is the contribution of Swiss food consumption to water, damage to water systems through both phosphorus and water extraction. And this is a really nice paper. So these are the countries in which there's phosphorus and water extraction damage being done to biodiversity. Here's where the biodiversity is being damaged from Swiss food consumption. Some places you might expect and some less so. And here, just out of interest, is the things that are damaging it, and maybe things that you might not expect. There is no red meat here. It's all about almonds. It's all about chocolate and things that we all love. It's a bit tragic, really. That's a story for countries. The same story is going to come for companies. So here is the Oxford Biodiversity paper again. And what we saw here is that regardless of what Oxford University does to try to avoid and reduce its impact, we're going to have a stack of offsets that we have to produce. That's this dark blue line here. So in the short run, we are going to have to offset a lot, and it's likely to be outside of our borders. Another example, this is food in Lady Margaret Hall that was led by Izzy Taylor and the Hatched. To get to nature positive, you have to be right at the top, basically. The hatch lines are the offset that you need once you've avoided and reduced your impacts. And again, and these are different scenarios of heavy to light avoidance, heavy avoidance to nudging that colleges could take. So again, a stack of offsetting will be required. How do people do offsets? So carbon offsets, this is how they do them. So you identify an area where you're going to do your offsetting, you calculate your credits using some standard, companies buy the credits, and then they say that those credits are offsetting their impacts. So that is not going terribly well at the moment. So we do have issues with the carbon offset credit market. How do we as biodiversity people avoid this trap? Here's a few suggestions. So the first one I still think is broadening biodiversity away from things that can just be remotely monitored. So use diverse, scale-appropriate measures that are including locally determined measures that are appropriate to the scale of biodiversity that you're impacting and the type of biodiversity that you're impacting. So not just forest cover, not just habitat, and not just things that come from the top down. Second thing, the thing that really stymied carbon offsets is the reliance on avoided loss counterfactuals. So reliance on scenarios of what would have happened in the absence of whatever it is that you were doing. And sometimes that's unavoidable, but really it shouldn't be the foundation of our biodiversity offset systems. We need to get on the ground. We need to measure actual biodiversity impacts, not potential biodiversity impacts. And we need to measure the effectiveness of mitigation actions over time in real life. I've kind of implicitly mentioned the mitigation hierarchy in the last few slides, but just to be clear on what it is, it's the hierarchy of what you do when you're trying to mitigate impacts on biodiversity. The first thing you want to do is avoid the impacts. That's the mantra that has to go. Impacts avoided are the best kind of things. So once you've done your best to avoid those impacts, then you would reduce them, then you would restore afterwards, but then you would offset. And that is the mitigation hierarchy. It's a precautionary hierarchy that we all have to stay really focused on and embed social justice and locally determined actions as well. Very nice paper that I sadly am not an author on, I wish I was, which came out a few months ago, which is about connected conservation. Their picture is in terribly low resolution, but I hope you can get it, which is basically to say that, we've got these financial accumulation centers, all the damaging flow to biodiversity is coming mostly from the global north, from big financial centers, and all the potentially positive actions are coming from the global south and much more local. So what we need to do is kind of align those big global flows of damage and money to the local bottom-up potential for actually making that change. And that also requires us to move away from metrics. I think we're so focused on metrics. So, the first question that people ask when, you go and talk to companies about nature positive is, what's the metric? Prue Addison led a paper that we were on that thought about this some time ago now, in which metrics come quite a long way into the decision cycle. First, you need to think about what you want to do. You need to think about your targets. You need to think about what's right for you. You need to think about your evaluation and your actions and your adaptive management. The metric is inside that framework. It's important, but it's not the only thing. So if you're thinking at a global level, it would look something like this. You have your global target and your global timescale. And then you would then scale down to sectors, companies, countries, individuals, communities, to try to think through what actions you could take to improve biodiversity, implement those actions, monitor, and the blue says this is where your metrics come in. And then you have your local adaptive management loop, and then you have your aggregation, using the methods I suggest perhaps, to scale up to think about how outcomes are integrating over scales, times, impact types, and then globally. This is another lovely graph, or depressing, but lovely. I like it particularly because it says that at the very, very end, in the end game, there will still be a Saiga. Look, there's the Saiga. Can you see it right at the end? So that's all right. So this paper, classic paper, really important paper, makes the key point that if we are actually going to bend the curve for biodiversity, we need to do two things. We need to do our conservation, which is the kind of yellow to green, sorry, the brown to yellow, but that won't take us to restoration. We also need to do our supply chain transformation. So the supply chain transformation uses the mitigation hierarchy. So that's when you're trying to take your direct impacts, you avoid them, you reduce them, you restore them, you offset them. But this other bit also needs framework. And that is the conservation hierarchy. So that is the same thing where in conservation terms, when you're trying to move forward and to be more proactive, you can also take the same approach of avoiding going all the way to us. It works like this. So you have your direct impacts that we can measure, and you have your conservation potential. So this is the areas of land that could be restored, the species that could come back, the urban areas that could have green walls, the streams that could be depolluted, and so on. And each of those can be mitigated and then offset on the impact side, but then on the potential side, you can then also, and I'm switching language now because I like the 4 R's: refrain, reduce, restore, and then renew. So avoid, reduce, restore. So on a global level, it looks like this. So this is the bending the curve again. You know, we've got our negative trend. We want to address our contemporary impacts and get ourselves to hopefully, you know, net okay. And then we want to address indirect, diffuse, and past impacts. So the impacts that can't be addressed using just mitigation of direct impacts on the ground to get ourselves to restoration. And we have our 2 pathways. So, you know, we could retain important biodiversity and not build on it, but we could also improve our protected area network. We could have green walls, we could have all these other things. So there's these 2 pathways, one of which is the mitigation hierarchy and the other of which is proactive. We can think about this at individual levels as well. So here's something that an individual could set themselves a target and a date, and they could use that target and date to think about their fashion choices and their food choices and how they're going to refrain, reduce, restore, renew. So I think this is quite hopefully a useful target. Okay, so I started off rather sarcastically by talking about the Holy Grail. And I hope I have given a little flavour of why I think the Holy Grail is not what we're aiming for. Sorry if you're disappointed and you thought that there was going to be a true biodiversity metric. Instead, I think if we're going to have cheesy analogies, the better one might be the crock of gold at the end of the rainbow. So the nature positive future is our crock of gold, but we need the rainbow to get there. So we need to have this diversity of indicators that we can actually then aggregate in order to get to a real good understanding of biodiversity that isn't compromised, that isn't losing the essence of what biodiversity is, which I hope is illustrated by this rather lovely meadow. Thank you. And I should say, sorry, before you cut, this is the product of a ton of thinking by many people over many years. And I showed the first authors, but there's many people now already within the Leverhulme Hub, within the Agile program. Many of my collaborators have talked to me over many years. So I'm just very grateful to everybody who's contributed to this thinking. Thank you.
Thank you, EJ. Fantastic overview. I'm sure we'll have lots of questions here, so we can open up to questions. I'll just kick off with one just to get things going. Fungibility, is this just for anything like offsetting or trading? Is this just a fundamental barrier because biodiversity is intrinsically local? We can't compensate for a housing development in Oxford by planting trees in Scotland, for example.
I think it's fundamental. I think we spent too long going down a rabbit hole of trying to look for a fungible biodiversity metric. And there are some out there who are saying that they are fungible, but I just don't think they can. I don't think you can have a meaningful contribution to biodiversity recovery with a fungible metric. I'm probably really wrong about that, but I have not seen a fungible metric that I think could do that. Has anyone seen one?
Okay, we can open up the floor.
I'm still searching for the Holy Grail. In Britain,
yeah,
all our measurements that we talk about now come from the 1970s. When you talk about a nature positive future, the thing that you want to achieve by 2050, although I would want to achieve it much earlier, but maybe that's all that is possible. It needs to be viable ecosystems. We know that what we're comparing with always is 1970. So do we want to move forwards to the same levels of abundance and diversity that we had in 1970. Now, I appreciate it could be different species and things because of climate change or whatever, but would that be a good goal to actually pick a date? Because at the moment with biodiversity net gain and so on, you say, oh, it's got to go up 10% from what is now, but now is going to be ever declining until 2030 because we've decided to wait until then. And so, yeah, shouldn't we go back to what was a more viable time?
We have to be aware of shifting baselines, and it was pretty depleted in 1970 in this country, very depleted in 1970 in this country. So 1970 is just when the Living Planet Index, for example, has some decent records. So that's why it's starting at 1970, when we started to get these records that we can use. So I wouldn't choose 1970. And as you say, we are going to have very different ecosystems. So we can't have the same species composition. We can't have the same ecosystem composition in the future as we had in 1970. We just can't. So I would say yes and no. So when you think about the green status of species, for example, what we've tried to do is we take a baseline of before major human interventions. So in Europe, the default is set at 1500. In island states where we know that it wasn't inhabited until later, we can set it later. So that the green status of species sets it boldly, I would say, at pre-human intervention. You then go down, and that's why the species recovery score cannot really get, and then we say, okay, when did conservation start? And we'll go from there. So the species recovery score can never get back to 100%. So we're never going to get back to pre-industrial levels. But it's the reason why that is a kind of mantra for the green status is that we should not forget. We should not forget that species are depleted, and wherever you start, you will get that problem. So this is why I say that you need to have a societal discussion about where we want our biodiversity to be. I don't think there's any single place for any single species or ecosystem which we can say, let's go to 1970. Instead, we should say, all right, so what would flourishing nature look like? And try to aim for that on a range of different dimensions. Have I answered the question?
Yeah, but not relative to...
Not relative to 1970. I wouldn't do it relative to 1970 because I think you'd sacrifice a lot.
Let's pick up on you mentioned pre-industrial or pre-human at different times as well, and those are problematic as well. You
absolutely
quite depleted by pre-industrial.
Many research papers can be written on this topic. It's great.
Okay.
In terms of the one true metric versus there isn't one, and in terms of a lack of fungibility being fundamental, I think it sounds to me like it makes sense. How do you convince companies who maybe want to be seen to be doing something but don't care that much?
Well, maybe they will. I think they care more than you think, and they care about their dependencies in particular. So I think another thing is not to let, and this is such a cliche, don't let the perfect be the enemy of the good. So like I showed with the EU thing, first approximation, potentially disappeared fraction for at least some elements of biodiversity will give you a start. It'll give you a kind of basic orders of magnitude that will help you to get in the right direction. I think companies need to start moving in the right direction. And for that, they need to have some basic understanding of where the biodiversity impacts are and in what place. So, you know, I'm actually quite positive about using PDF as things stand for companies to start with. The other thing is, if you have a proper theory of change that takes you to biodiversity outcomes, but includes processes and drivers, then you can start to get people moving. So to, you know, by the end of the year, you could have yourself a biodiversity strategy again, and you could have a commitment to report transparently. This is what we're doing in nature positive universities, by the way, is that you start easy with, okay, have you got yourself a strategy? Have you got a committee? Have you got a reporting date? Do you know what you're going to try and do first? Then you start to think about, all right, so some biodiversity outcomes are quicker than others. So if you want to have a wildflower meadow, then in a few years, you can have a wildflower meadow. That's a proper biodiversity outcome. Other things, the drivers it takes longer. And then you might start by measuring the drivers with a view towards the biodiversity outcome being something that you see in the longer term. I think we can't, if you start to expect miracles, you'll get stasis.
So on that issue of fungibility and the rationale behind the compensation or biodiversity offsetting, are you suggesting then that a localized approach or particularized accounting be applied with the offsetting as well, so that roughly the impact an entity is having is quite specifically offset for?
Yes. Yes. So I think what we need to do is start to think about really pushing for traceability and sourcing, so that companies can understand where their supply chains are going. They can understand where the biodiversity impact is, and actually some of it will be diffuse. So some of it will be through climate change, carbon impacts. Some of it will be through pollution, which is much harder. So it won't all be land based here, but much of it will be. And so you can start, if you can get traceability as a real, if you're thinking of a process indicator, trying to understand where your sourcing comes from is a big process indicator. You then get an understanding of, maybe my top 5 impacts, where in the world those top 5 impacts are, and then start to think at that. And then you'd have a landscape, and you say, in this landscape, what are the kind of local entities? Where are the indigenous peoples, the local communities? Where are the people who are stewarding land as we stand, who we can partner with in order to improve biodiversity, both for their own local needs, but also with respect to our impacts? That's what I would like to see. So you would have much more traceability, and then start to think on a local level about what are these biodiversity indicators. Some of them will be global, some of them will be things that are relevant to your company or to the global biodiversity framework, and some of them will be very local, and you need to do both.
Thanks. Thanks for a great talk, EJ. I guess first, a concern about whether the grass really is that much greener on the climate side, because colleagues here in geography and physics would also be quite critical of CO2 equivalence metrics. And even in Mike's food system paper you showed, we had to use an alternative equivalence approach in order to maintain that link with temperatures. So there's still issues for the climate fungibility as well. But I guess a success of the arbitrary simplifying equivalence we do use is that it's got governments to kind of sign up to quite clear targets. So when you're talking to policymakers, how do we get that balance of needing the detail and the understanding that biodiversity is locally specific, and giving them something to actually drive towards in terms of positive change?
Yeah, I mean, I agree with you on the grass greener thing. But so they have signed up to halt and reverse biodiversity loss by 2030, bold target. So they do have that, and they do have a set of metrics. And so that, I mean, where we need to help them is how to aggregate those metrics, how to aggregate up so that they can actually report sensibly. They've already been reporting since 1992 on their biodiversity action plans on the Rio summit. They've been reporting on an annual basis, but until recently, there's been very little ability for those reports to actually be aggregated and demonstrated that biodiversity as a whole is going in the right direction. In fact, it isn't, but so we have a bit of a mismatch at the moment between global biodiversity indicators that are showing downward trends generally, and all those kind of biodiversity action plans at the national level, which aren't adding up to shifting that curve. And so if we can get a little bit more of a circular thing, which is why I think that really pushing the frameworks, we can get some circularity, some link between what governments are doing and reporting and what's happening with indicators, then we can start to get a little bit more traction, I think. Maybe that's unlikely, but it's worth a shot. Henry. Is someone online, by the way?
Thank you, Dame EJ. I wanted to ask again about avoided loss. I know that you said in the talk avoided loss, but I'm really falling out of love for avoided loss offsetting as a methodology at all. I think it's a complete charlatan way of doing things. Are there any cases where you think avoided loss offsetting does have a purpose, does work, or does serve a purpose? Because I don't see that it's compatible with nature positive future in any way. It just slows down loss.
Yeah, I mean, I think I guess with red credits, you know, if you've got standing forest that is good standing forest that is being managed and that money needs to go into that forest in order to continue its management. I'm thinking of, you know, some of the big forests in Cambodia, for example. In the absence of an avoided loss counterfactual, it's really hard to know how that management for you know, that management can actually get funding come into it. So in an ideal world, you would have a kind of you would have intergovernmental funding that would support the conservation of existing nature, and you wouldn't need to kind of invoke avoided loss in order to find ways to preserve that standing forest. As things stand, this is an important source of finance revenue for lots of important standing forests with important nature in it. So I wouldn't chuck avoided loss out completely, but you know, and there are sophisticated ways to do a counterfactual that means something, but I think there's a lot of temptation to shoehorn projects that shouldn't be in there through rather abstruse argument about avoided loss. And the problem with the problem with biodiversity credits in general, or impact compensation, let's say, is it has to be additional. If it's not additional, then it's not proper. So, you know, you have to have that avoided loss narrative unless you're doing restoration. So restoration, but then that then comes up against the mitigation hierarchy, because the first thing you do is avoid, the third thing you do is restore. So you don't want to go around not avoiding, you know, so the avoided loss and the avoidance part of the mitigation hierarchy are slightly kind of awkwardly aligned, because the avoidance part of the mitigation hierarchy says, do not cut down standing forest. And then you say, okay, so be additional. And those two don't quite align, which is why, I mean, yeah, I don't think you can get rid of avoided loss arguments entirely, but it's really tricky. Oh dear.
Yeah, thanks so much, EJ. Yeah, so the result of all of those biodiversity footprinting analyses is that, like, we've got these huge impacts embodied in our consumption. The Oxford one shows that even if essentially, like, we can reduce our footprints by 2/3 through behavioral, for the most severe, behavioral measures. So my question is, do you think conservationists should be more explicitly anti-consumption?
Yes. We need a systemic transformation of our social ecological system. Of course we do. Absolutely. Of course we do. And the question then is, for me, is how do we make that transition? That's the tricky question, isn't it? In the short term of that transition, we're going to need to have lots of financial flows into biodiversity conservation to keep what we've got while we make that transition. We should all be voting and influencing as much as we can to push towards that societal transformation that we need. Otherwise, we're the species that's going to suffer.
Okay, there's a few online I'll relay. One from Paul Stewart Smith. Are you seeing, that's a good follow-on. Are you seeing any signs of the systemic change needed to achieve target 2 of the global biodiversity framework, 30% of degraded terrestrial and marine ecosystems under effective restoration?
Yeah, I'm interested that you've chosen the Paul, thank you for the question. I'm interested that you've chosen the protected area target as the one, because that's the one that I think is least dependent on systemic change. That's the one where we could continue, you know. I mean, I don't think that the 30% target is that much of a stretch target. I think the stretch targets are the ones around consumption and production, so the drivers of biodiversity loss. We need to have more protected, more and better managed and more socially just and equitable protected areas. I feel that's quite achievable in the current system. I think what's not achievable is the other chunk of it, the changes in the supply and consumption. But I might be wrong. And my answer in terms of, are we seeing the systemic change? Oh, well, you know, you read the news as much as anybody else as I do. I mean, I think we're seeing some of it, and we're seeing some in the opposite direction. And I also feel like the more biodiversity comes up the agenda and starts to become a really salient issue, the more we have to be aware of the nature loss skeptics, the pushbacks of the vested interests. So just as climate change has pushbacks of vested interests, we're going to start to see more and more pushback of vested interests. So we stop being a cuddly issue of let's save the elephants in a far off country and start to become an issue that actually hits the pockets and the way of life of the people in this country. And that is when we're going to have to. So I think there are glimmers of hope. Of course, there are green shoots of people really, really, really care about nature. They really do. But, you know, how are we going to change that into something that causes systemic change against a strong prevailing wind from vested interests? That's what we've all got to do together, isn't it?
Okay, great. I'll read out a couple more from online. Kendall Jones, I agree that field-based assessments like the species green list and LPI are very useful, but they require an on-the-ground knowledge on specific species or elements of biodiversity. Getting such data is very resource-intensive and likely difficult for many nations to achieve. Do you see any scope for the use of composite ecological integrity metrics, which incorporate remotely sensed measurements of things like human pressures or vegetation structure to help measure and communicate results at a broader scale, even if they're often less accurate than field-based metrics? North Star metrics like these have been very useful to catalyze action in other fields, such as climate and human development.
I do think that there are composite ecosystem integrity metrics that are useful. And again, I think, you know, I'm not going to say negative things about any one metric. It's just that we need more. We need a range of them. So I think a composite ecosystem integrity metric that can be remotely sensed and then be supplemented by field-based data where possible would be great. Just to note that the green status of species is an expert assessed index. It's not based on real world on the ground data as such. It's based upon the expert judgment of the species specialist groups, which is thousands of people who have, you know, experience on the ground. So you can do an index that is expert based. I think there's a lot of potential for novel indicators, eDNA, for remotely sensed indicators, but I don't think that they substitute entirely for on the ground assessment. And then if we go back to, you know, none of this substitutes for proper engagement with the stewards of the land on the ground. So none of it substitutes for supporting and engaging with local communities and Indigenous groups. And that is the way, I think, to get this bottom-up approach to complement and supplement the top-down. So agreeing and disagreeing.
Great, thank you. There's a few more online, but I think we'll probably stop there. And there are drinks in one of the rooms, atmosphere room, is it? Just along this corridor. So let's move to an informal conversation. And everybody's welcome to join us there. But finally, thank you, EJ, for both giving us a 101 on biodiversity metrics, which I think was educational to all of us, but also played a really important role in leading and pushing and collaborating, and lots of these are really critical topics for us as well. So thank you very much, EJ. Good.